Hello, everyone. Thank you for joining me for today's webinar on our new HOBOnet multi-depth soil moisture sensor. With you today, I'm Richard Rodriguez, Product Marketing Manager for Outdoor Environmental and Agricultural Products at Onset. I've actually recently joined Onset in the past year or so, and my experiences in working with agricultural researchers and growers, universities, and different environmental agencies. Today's webinar will be recorded and will be available for viewing by anyone on our website. You will actually get a reminder of this or notice of this in the next 48 hours. If you do have any questions, please feel free to enter them at the bottom of the control panel in the tab called questions. And my colleague Jessica will be monitoring those for me. I will then do my best to get through as many of those as we can at the end of the webinar. Now, for those of you new to Onset, Onset has been designing, engineering, and assembling its own products in Cape Cod, Massachusetts, more specifically in Bourne, at our headquarters in since 1981. So we're not no startup, not new. We've been around for some time, and for almost 40 years, we have been trusted by researchers for providing durable, trustworthy data loggers that will provide the much needed information when that info is needed. Now, what brings us here today? So measuring soil moisture at a single point can lead to incorrect irrigation decisions for growers or for researchers. It can create an incomplete picture. Why? Well, water is absorbed quicker where the majority of root plants or a plant's active roots are, which is typically closer to the surface. Water loss due to evaporation is also greater closer to the surface, and then soils may also not be uniform at different depths, which will impact water retention. So because of these factors, moisture available to plants will vary immensely depending on depth. And so depending on the crop you're looking at or the plants that you're studying and their root depths, they may be experiencing something very different at different depths. So knowing the soil moisture at several depths will allow you to track the health of your plant at its active root zone during the whole crop cycle. Also, with multiple points of measurement, you can measure moisture levels at different soil rises. You may also want to follow water depletion and the depth of irrigation water penetration. I like to try to get my roots to extend deeper into the ground by seeking water at greater depths, so I will track moisture and avoid watering until that water moves out of the reach of the active roots. Well, to answer this need, we are introducing the HOBOnet multi-depth soil moisture sensor. This solution profiles soil moisture and temperature over several depths with a single device that is quick and easy to deploy. It's also accurate and very durable. This product consists of a sensor available in 3 lengths and a HOBOnet data logger in communications mode. For the multi-depth sensor, we elected the Grow Point Profile, a well-known product out in the market, and is known for a few key features, which make it a very capable and probe well suited for real-world applications. So let's take a look at the HOBOnet multi-depth wireless soil moisture sensor and what makes it a great or makes the Grow Point Profile probe that we chose so good. Well, to start, unlike other multi-depth soil moisture sensors, which measure soil moisture at discrete discrete points, like as you see here on the left side of the image. You basically have 4 discrete soil moisture sensors measuring soil moisture at these specific points. The grow point soil moisture sensor actually measures soil moisture along the entire length of different separate 15-centimeter sections, which run the entire length of the probe. The advantage of this is that different objects in proximity to the probe will have less of an effect on soil moisture readings. So if you see this rock here up against the probe on the left, that third depth point will have soil moisture readings that are greatly distorted by the presence of that rock, as that rock occupies or influences a much larger percentage of the volume of influence of that single sensor. On the other hand, when you look at the grow point sensor that we are using, that same rock is affecting a much smaller percentage of the volume of influence of the grow point sensor. And because of that, that rock will lead to much less or have a smaller impact on the accuracy of your reading. So if like I mentioned earlier, in real world applications where unlike in the lab, you have different changes in the soil, we'll actually be able to provide you better readings. We have 3 sensor lengths to choose from: an 18-inch or 45 centimeter, a 24-inch or 60 centimeter, and a 35-inch 90 centimeter option. In addition to increase in volume of influence due to covering the entire length of the sensor, the antenna design increases the area around the probe measured, giving this the largest volume of influence for multi-depth soil moisture sensors. GrowPoint's TDT5 technology, basically a more refined version of TDR, and advanced filtering of 400,000 pulses per measurement, filters out noise, which then provides you more accurate and repeatable results, which again are more important or very important when you're looking to make irrigation decisions. Installation is actually quite easy with these. I recently deployed the 35-inch probe using the installation accessories that we will also be offering on our website in 103-degree weather here locally in high clay content ground. And it took about just around 60 seconds or about a minute to get a hole created and a probe deployed. Actually available on our website at that deployment. I will get into a little more detail regarding the deployment of these as it is different from standard multi-depth soil moisture sensors. A little more detail regarding the large sampling and filtering of the GrowPoint multi-depth soil moisture sensor. So the antenna running along the entire length of this sensor is actually woven 20 times per centimeter, which gives this antenna 5 times the physical length it occupies, allowing it to create a wider area of measurements around itself. This increases the resolution and sampling area, which then again, in turn, provides you more accurate and repeatable results. The sensor element is also not exposed to the soil, so there's nothing to bend and break. If you look at this, or look at a cross-section of this, the circuit board is completely sealed in an epoxy sealant, and then that is jacketed in a polycarbonate housing. So even if there is a slight crack or any damage that occurs to the outside housing of the soil moisture sensor, the epoxy sealant will protect the circuitry from the elements, allowing you to to have greater peace of mind during deployment. We leave these sensors deployed year-round through different conditions. With this, our soil science portfolio for HOBOnet is looking quite good, or quite large compared to what it looked like when we entered this year. We continue to offer the low-cost soil moisture sensors with a Decagon, EC5, and 10HS. These are also the only options currently available with a plug-and-play type option. For higher accuracy and durability, the Teros 11, which also includes a temperature measurement, is a great product which we launched in first quarter this year. The Teros 12 will also provide you electrical conductivity for the soil and has a similar form factor to that Teros 11 with the stainless steel spikes, which are very durable, and also features a very large volume of influence to provide you very accurate results. The Teros 21 also provides highly accurate soil water potential and temperature measurements in a very durable product. And then as you can see on your screen, the Grow Point multi-depth soil moisture sensor measures volumetric soil moisture content and temperature similar to the Teros 11, but will do so over several depths. This is part of HOBOnet, the HOBOnet wireless sensor network. Basically, it's our cost-effective way to remotely monitor multiple points in a field without having to run wires or travel from point to point to collect data. All that data comes to you. So a little bit about HOBOnet. HOBOnet requires a central station and then allows you to deploy sensors around that central station, where each sensor is connected to a communications device. These communications devices can actually have a range of up to 1,500 to 2,000 feet from sensor to sensor. And this is line of sight range. We selected a self-healing mesh network, which means that these sensors actually communicate to each other and through each other to get to the central station. So in effect, you can place a sensor, extend the range from the central station to your farthest out sensor by up to 5 hops, meaning 5 sensors worth of distance. So you take that 2,000 feet maximum line of sight range from sensor to sensor, and meaning you can actually reach a radius of up to 10,000 feet away from that central station. Because it is a self-healing mesh network, the sensors will always find the most efficient path to communicate their data back to the central station. So if there is ever any damage done, any reason for one sensor to go to be decommissioned, the other sensors around it will find other paths to get to that central station. These are all solar powered, so the batteries in them do recharge when they're exposed to the sun, and so you can really leave these deployed year after year without really needing much in terms of maintenance or any maintenance at all. As part of HOBOnet, key system components will be your RX station. So we have 2 options for that. Your wireless sensor, of which we have several options, and you can, in addition to soil moisture sensor, we have a large number of other measurements that we can provide. And then all the data can be viewed through our cloud platform, HOBOlink. In addition to viewing it in HOBOlink, you can have set these up to share data automatically with the public. So if you have a website and you want to share this data, that can easily be done. You can have data automatically exported so that you can integrate the data with your own systems if preferred. and you would use HOBOlink to set up your system and set any alerts, any triggers that if certain thresholds are met in either terms of temperature, wind speed, soil moisture, you can get a text message or email alert informing you of those conditions. In terms of selecting a station, the RX2100 series will actually be the best solution for most applications, or many applications. It is a lower priced option. However, it is available in the cellular connection, cellular option only. So if you do have the option for either an Ethernet or Wi-Fi connection, you would want to look at the RX3000, as it would actually save you some money over a couple of years. The RX3000 also enables you to measure water level in addition to having the wireless sensors connected. It has a higher capability or capacity for wired connections, so you can do up to 10 wired sensors with the RX3000 in addition to 50 wireless sensors. And then it also enables you to connect a 4-channel analog input, which allows you to connect third-party sensors with an analog output. And also gives you the option for a 3-channel relay. I mentioned having the system provide alerts via text message and email, but it can also trigger an event, maybe start a pump, for example, for irrigation in the event that frost temperatures are being experienced. Looking at cost, the RX2100, which would be the more typical solution for outdoor applications, it includes a solar panel and your HOBOnet manager that starts at that comes in at $770 compared to the RX3000 that is priced at just under $900, but then would require you to also purchase a solar panel and the HOBOnet manager. And then the sensors start at $690 for the 18-inch version and go up to $990 for the 30-inch version. And then you would also want to purchase a data plan for most applications. Now, we do have some options with limited data uploads, which can come in at no cost, including the Wi-Fi and Ethernet. But for your standard 4G cellular connection, you're looking at starting at $150 per year. And then depending on how many sensors you've got connected and your logging rate, your data upload rate, we do have larger data plans that come in at $350 per year. There are some additional limitations for anyone familiar with HOBOnet because of the size of these sensors and the number of, the number of measurements taken by each of these. There are certain limits. First, the number of devices you can connect to a station. I mentioned earlier that they've historically had a limit of 50 wireless sensors. However, now we are specifying the number of data channels, which is 336. The reason for this specification is that these sensors have occupy several data channels because of the number of soil moisture and temperature readings that they take. So you're actually limited with up to 18 devices when you're looking at the longest probe in this case. For battery life, for solar powered batteries, if you follow our advice on logging rate, you'll be okay. The batteries will have plenty of time to recharge before the next reading. For the 3 segment or 30 centimeter option, you're looking at a 5-minute logging rate a year round. For the 4 segment 45 centimeter option, we'd recommend 5-minute logging during the summer when there is enough sun energy to recharge the batteries. But then in the winter, or as you get into the winter, that should be changed to 10-minute logging in order to allow the batteries sufficient time to recharge. For non-rechargeable lithium batteries, the logging rate should be slower in order to enable batteries to last up to a year or over a year in deployment. Now, installation. Unlike other multi-depth soil moisture sensors, which would require digging out a hole, typically using an auger, and then having to backfill, possibly backfill the hole, which can cause some disturbances in the soil. This sensor is actually not round. It has an X profile, and we provide a pilot rod with that same profile, X profile, with the same dimensions as the sensor, and this would be attached to a slide hammer, and that slide hammer will drive the pilot rod into the ground, creating an X profile in the ground, which you can then insert the probe into. This again takes, for the longest probe, it takes about a minute to perform. The great thing about this is that it pushes the soil out of the way, and then after you insert the probe, that soil, as it relaxes and fills in any gaps with the soil moisture sensor, you get a nice tight fit between the soil and the sensor, which you want in order to get that get those accurate readings that you're looking for. Another point to note in differences between our HOBOnet device setup and other wireless systems is that we have a radio or communications device tied to every sensor. So basically, you have a sensor placed with a radio right above ground, where with other sensors you have a central station with perhaps 3 or 4 sensors coming off of it, which would then require you to dig out channels to run cables from the sensor to the communications device, which means that it's 1, more labor intensive, and 2, you now have cables running underground, which can be damaged when running equipment or doing certain activities above ground. We have, as mentioned, three different lengths. So part numbers for 3 different lengths, and then we do have specific radio frequencies for different areas of the globe. So from North and South America to Australia, New Zealand, Europe, and Taiwan. So on our website, when you do select the product, we will prompt you to first select your length, the length of your probe, and then second, select the location where this will be deployed. We do sell both the slide hammer and the pilot rod separately. So the pilot rod, you may need 1 or 2 different lengths depending on the number of sensor types you're deploying, and then these are easily interchangeable with the slide hammer. And with that, we conclude our webinar on our new multi-depth soil moisture sensor, and I will be open to any questions.